At 3:42 a.m. on October 7th, 2024, Robert Lindstrom stood at a hydraulic control station overlooking 520 acres of Wisconsin cranberry marshes near Wisconsin Rapids. Watching real-time flow monitors show 847,000 gallons of water flooding into his beds while needing 18.4 million gallons total to submerge 52,000 barrels of cranberries worth $4.16 million for mechanical harvest. But his primary pumping station, delivering 3,200 gallons per minute, had suffered catastrophic bearing failure at 1:15 a.m., forcing reliance on backup systems running at only 1,920 gallons per minute, creating a flooding timeline that would take 14 hours instead of the required 8 hours, leaving fruit exposed on vines past optimal harvest window and triggering ocean spray contract penalties of 12 cents per pound for delayed collection, affecting quality scores. 63 years old and third-generation cranberry grower operating the second-largest wet harvest operation in Wisconsin, managing engineered wetlands requiring the coordinated flooding of an area equivalent to 395 football fields, using water volumes matching 28 Olympic swimming pools, moved through 12 miles of irrigation channels, dikes, and reservoirs. The cranberries had reached perfect harvest specifications, deep crimson color indicating 12.8% sugar content, firm texture from overnight temperatures dropping to 38 degrees Fahrenheit, and the natural air pockets making fruit buoyant enough to float when submerged. But the harvest method required complete submersion, transforming solid ground into navigable water, deep enough for mechanical pickers that couldn't operate until every acre sat under 18 inches of precisely controlled flood. Standard procedures said shut down operations, repair the primary pumps, and delay harvest 36 hours until full pumping capacity could execute proper flooding protocols. Lindstrom had 280 acres already harvested and delivered. Processing facilities contracted to receive his remaining 15,600 barrels starting at 11 a.m. today. Ocean Spray's quality inspector scheduled to verify water depth compliance at 7 a.m. And weather forecasts showing hard freeze arriving in 48 hours that would damage any unharvested fruit still on vines. He opened emergency spillway gates on his upper reservoir holding 6.2 million gallons in reserve storage. They'd supplement reduced pump flow with gravity-fed reservoir discharge, flood the remaining 240 acres using combined hydraulic systems never designed to operate simultaneously, and risk catastrophic dike failures from uncontrolled water surges to protect the $998,400 in revenue those beds represented. Wisconsin's Cranberry Wetlands operate as America's dominant fruit production region through industrial-scale water engineering, 21,000 acres producing 5.4 million barrels annually, supplying 60% of U.S. cranberry consumption through wet harvest systems where growers flood entire farms, transforming solid ground into shallow lakes. Mechanical pickers called egg beaters drive through the crimson water-churning vines to release floating berries, and boom corralling systems gather millions of pounds of fruit into concentrated collection zones for pump truck extraction, moving product from flooded marshes to processing facilities within hours. Every September and October, Wisconsin growers coordinate the flooding of thousands of acres using reservoir systems, irrigation channels, and pumping stations, moving hundreds of millions of gallons of water across engineered landscapes, where precise depth control determines whether cranberries float for mechanical harvest or remain attached to submerged vines, making collection impossible. This is agriculture operating as hydraulic engineering, where growing the crop represents 40% of the operation while managing massive water movements for harvest constitutes 60%. Equipment failures during flooding cycles cost hundreds of thousands in delayed harvest penalties. Broker and the entire system depends on transforming dry land into navigable water bodies deep enough for machinery, but shallow enough to maintain berry quality. A precision that catastrophic pump failures destroy completely. Robert Lindstrom learned cranberry production from his father, who established the wetland operation in 1976 when Wisconsin growers were transitioning from dry harvest handpicking to wet harvest mechanical systems requiring massive infrastructure investments in dikes, reservoirs, and pumping stations. His father had operated 120 acres with gravity-fed flooding from adjacent streams, achieving modest yields while avoiding the capital costs of engineered water control systems. Lindstrom expanded in 1998, increasing to 520 acres, invested $3.8 million in reservoir construction and diesel-powered pumping stations capable of moving 3,200 gallons per minute, and developed ocean spray contracts, paying premium prices for high-volume deliveries meeting strict quality and timing specifications. But hydraulic system sophistication created new vulnerabilities. When pumping infrastructure failed during harvest windows, the entire operation faced contract penalties and quality degradation that simple gravity-fed systems never risked. The pumping station Lindstrom operated cost $1.2 million to construct in 2015. The facility housed 3 diesel pumps, one primary unit delivering 3,200 gallons per minute, and 2 backups each rated for 1,920 gallons per minute, drawing water from a 40-acre reservoir holding 6.2 million gallons in storage capacity built by damming a tributary stream. The system flooded cranberry beds by releasing reservoir water through 12 miles of irrigation channels controlled by 48 hydraulic gates, filling beds to 18-inch depths that submerged vines while allowing cranberries' natural buoyancy to lift fruit to the surface where mechanical pickers could collect them. The process worked flawlessly for 9 seasons. Then bearing failure in the primary pump destroyed the precisely timed flooding sequence that harvest protocols required. The economics were contract-dependent and timing-sensitive. Now at ocean spray rates of $80 per barrel for cranberries, meeting quality specifications delivered within harvest windows. Production of 52,000 barrels generated $4.16 million in gross revenue. Reservoir and dike maintenance costs ran $68,000 annually. Pumping station operations, including diesel fuel, $42,000 per season. Mechanical harvesting using rented egg beater pickers, $18,000. Boom corralling and collection systems, $12,000. Labor for flood management and harvest coordination, $94,000. Frost protection systems preventing spring damage, $38,000. Processing and delivery, 22 cents per pound, or $286,000 total. Combined costs, $558,000 against $4.16 million revenue, leaving $3.6 million operating profit after equipment depreciation and land costs. Actual net income around $1.24 million. But if pump failures delayed harvest triggering ocean spray's 12 cents per pound late delivery penalties, revenue dropped by $374,400 and profit collapsed to $865,600. A 30% margin reduction from equipment failure occurring during a 48-hour critical window. The difference between full profit and penalty-reduced earnings was maintaining 18-inch water depths across 520 acres using pumping systems designed with zero redundancy for catastrophic primary pump failures. At 5:20 a.m., Lindstrom had opened the emergency spillway gates. Water from the upper reservoir began flowing through channels at 840 gallons per minute, adding to the 1,920 gallons from backup pumps for a combined flow of 2,760 gallons per minute. Still 440 gallons short of the 3,200 design capacity, but enough to complete flooding by 10 a.m. if discharge remained constant. The risk was uncontrolled. Reservoir release through spillways designed for slow discharge, not high-volume flooding, created surge pressures on downstream dikes that engineers had rated for gravity-fed flows, not combined pump and spillway operations. If dikes failed from excessive pressure, uncontrolled flooding would destroy beds, damage equipment, and violate environmental permits regulating discharge into tributary streams. His son Peter arrived at 6:10 a.m. to help monitor the flooding operation. 34 years old, holding a civil engineering degree from University of Wisconsin. He'd worked the operation for 9 years while recognizing that cranberry production had evolved from agriculture into industrial hydraulic management, requiring expertise in water flow dynamics, structural engineering, and contract logistics that had nothing to do with growing fruit. Peter tracked data showing Wisconsin cranberry operations consolidating from 340 growers in 2005 to 185 in 2024, with average farm size increasing from 62 to 114 acres. Small operations were disappearing as infrastructure requirements and mechanical harvest investments created barriers favoring either large operations with redundant pumping systems or complete exit from cranberry production. Dad, we're running spillways and pumps simultaneously in configurations the system wasn't designed for. If the lower dike fails from surge pressure, we'll flood the county road and trigger DNR violations. That's the choice. Accept harvest delay and ocean spray penalties, or risk infrastructure damage to maintain flooding schedules. Then, maybe we've built a system with no failure tolerance. Large operations running 2,000+ acres have backup pumps matching primary capacity. We're gambling the farm on equipment that can't absorb single-point failures. Lindstrom understood. His son was identifying the structural vulnerability. Mid-sized cranberry operations had invested in infrastructure adequate for normal operations, but lacked the redundancy and capital reserves to handle catastrophic equipment failures during harvest windows when timing determined contract compliance. By 9:40 a.m., the flooding was 78% complete. Water depths across most beds measured 17.2 to 18.4 inches, acceptable for harvest. With 3 beds in the western section showed 15.8 to 16.4 inches, marginal but potentially workable if cranberry buoyancy could lift fruit in shallower water. Ocean Spray's inspector had arrived at 7:15 a.m., sampled water depths, and noted the variance in his compliance report, but authorized harvest to proceed given that 89% of acreage met specifications. The mechanical pickers rented egg beater machines with rotating tines that churned water and agitated vines, releasing berries. Entered the flooded beds at 10:20 a.m. The harvest process was industrial-scale collection. Machines drove through the crimson-stained water, creating turbulence that dislodged cranberries from vines. Floating fruit accumulated on the water surface, creating dense mats of berries. Workers deployed boom systems, floating barriers corralling fruit into concentrated collection zones. And pump trucks extracted berries from water, moving them into bulk trailers for processing facility delivery. The system processed 15,600 barrels across 240 acres in 8 hours, completing harvest by 6:40 p.m. Final season economics after the pump failure crisis. Emergency spillway operation had worked without dike failures, but surge pressures had damaged 2 gates, requiring $18,400 in repairs. The partial depth variance in western beds had reduced cranberry recovery by 8% in those zones, costing 420 barrels at $80 each. $33,600 in lost revenue. Combined crisis impact, $52,000 in additional costs and lost production. For net income, $1.19 million versus projected $1.24 million. A 4% reduction from a single equipment failure during a critical 48-hour window. Robert Lindstrom continued cranberry farming through 2026, managing hydraulic systems and contract timing while watching margins compress as diesel costs increased 28%, and ocean spray contract prices remained flat at $80 per barrel. In spring 2027, Ocean Spray announced new sourcing requirements. Cranberry suppliers must deliver minimum 100,000 barrels annually beginning in 2028, a 92% increase over Lindstrom's current 52,000 barrel production. Meeting the requirement meant expanding to 1,000 acres and investing $4.2 million in additional reservoirs, pumping capacity, and dike infrastructure. He met with Peter in April 2027 to discuss expansion feasibility, and the analysis was prohibitive. $4.2 million infrastructure investment against current net income of $1.19 million annually meant 3.5-year payback, assuming zero equipment failures and perfect harvest timing. Assumptions the pump crisis had proven unrealistic. Peter had zero interest in inheriting debt-financed expansion into an industry where processor consolidation was systematically eliminating mid-sized growers through volume requirements. Peter, we either scale to meet Ocean Spray's minimum and build redundant pumping systems, or we exit processing contracts and compete in fresh fruit markets at $52 per barrel instead of $80. Dad. Both options depend on buyer terms we don't control. Expansion locks us into Ocean Spray dependency. The fresh markets mean competing without the harvest volume that justifies our infrastructure costs. Robert Lindstrom sold his 520-acre cranberry operation to a regional agricultural corporation managing 3,800 acres across central Wisconsin in fall 2027. The sale, $22,000 per acre for developed wetlands, plus $1.8 million for pumping infrastructure and equipment, generated $13.24 million gross. After settling debt, Lindstrom netted $6.4 million. Peter took a position with Wisconsin DNR as a wetland hydrology specialist, using his civil engineering education and family cranberry knowledge to regulate the water management systems that had consumed his family's operation. Wisconsin's 21,000 acres continue producing 5.4 million barrels of cranberries annually through wet harvest systems flooding thousands of acres with hundreds of millions of gallons of water, operating mechanical pickers through crimson-stained marshes and supplying 60% of U.S. cranberry consumption. The hydraulic gates control water flow regardless of farm ownership. The pumping stations move millions of gallons, regardless of who built them. The mechanical harvest proceeds, regardless of which families engineered the flooding systems. The industry persists through massive-scale water manipulation that family operations pioneered, but can no longer sustain profitably at scales too small for redundant infrastructure and volume commitments processors now demand. If this story moved you, please like and subscribe. Your support helps us preserve these histories of American agriculture's transformation. Tell us in the comments where you're watching from and whether you understand the hydraulic infrastructure pressures crushing specialty crop growers. Thank you for keeping their stories alive.